Welcome back to the lab. In this experiment we're going to be looking at some equilibrium electrochemistry, specifically metallic corrosion and electrode potentials. These are important for understanding how corrosion occurs and how to protect against it, as well as creating better chemical batteries. Let's get started. In part A, you'll first investigate aqueous corrosion using an indicator gel and some nails. In part B, you'll go on and set up some electrochemical cells and measure some reduction potentials. And in part C, you'll use a pH meter to establish a relationship between EMF and pH. In part A, we're going to first investigate the aqueous corrosion. We'll do that by preparing two nails. The first is a plain steel nail. You'll see it has that sort of shiny metallic color. And around one end, you'll wrap a piece of copper wire. I'd recommend the head of the nail. Once that's done, you'll prepare a second nail, which is a galvanized nail. These are a much duller gray color because they're coated in a layer of zinc. So what we want to do is to one half of that nail, we want to expose that zinc, which we can do by dipping it into some concentrated, or quite concentrated hydrochloric acid. You'll see it bubble quite vigorously, and it probably takes upwards of a minute or two for the zinc to be removed completely. Once that's done, you will take some DI water and wash the acid off, after which you'll dry it with some acetone. The agar gel contains three important chemical species that can help us visualize what is happening at the cathode and anode of each of the nails. The first is sodium chloride, where it allows for the conduction of electrons between the cathode and anode of each nail. The second is phenolphthalein, which, as you should know, turns pink in basic conditions, and in this case will help us to visualize any reactions that are producing hydroxide ions. The third is potassium ferrocyanide, which reacts with ferrous iron ions, or Fe2+, to produce a blue color. In part B, we're going to be measuring some reduction potentials of metals and their corresponding metal ions. In this case, I'm going to look at some copper. So the first thing I want to do when I collect my electrode is to remove the outer layer of metal oxide. So I do that by just rubbing it gently against some sandpaper on both sides. And you want to be careful which metals you do this with. For example, you don't want to do this to a lead electrode because you'll put lead particles into the air and potentially breathe them in. So once that's set up, I'm ready to go. I can start with my metal ion solution, which in this case is copper sulfate. And into that I will put my copper, the same corresponding metal. And that's going to plug into the EMF meter. You've used this for pH previously, and we can use it for EMF with this small adapter which just attaches to the top, and plug it into either of those inputs. Into the other beaker, I've poured out some potassium chloride, into which I'm going to stick my reference electrode. It's a saturated calomel electrode, and that just plugs into the other side. Now, for those of you who may have noticed, this is currently an open circuit, right? There's no real connection between these two things. So we need to bridge that connection. And we do that by using a salt bridge. It allows for the conduction of ions between our solutions. So we just stick that in like that and make sure they're also completely immersed. And now we are ready to start measuring. In part C, you use a glass membrane electrode to measure the EMF of a variety of buffer solutions of different pH. You'll then establish the relationship between EMF and pH and use that to find the standard electrode potential of the probe. So you should now understand electrochemistry and reduction potentials a little better. We hope that this series overall has been helpful in acclimating you to a chemistry laboratory environment, and we would very much appreciate if, when you're doing your unit feedback, if you could leave any comments on whether these videos were helpful to you or any ways in which we could improve them. That's it from me. What's that? But, oh, no, it's the end.